Section 3.7, Graphing Linear Inequalities. So to graph a linear inequality, you graph it as if it was y equals mx plus b. The only difference thing is you connect the dots and shade. So to connect the dots, you don't draw just a solid line anymore. So the inequality, if it doesn't have an end equal to, it's a dotted line. Because less than end, so if it's like, say, x is less than or equal to 4, that means a solution can be on that line. If it's just x is less than 6, that means it cannot be on that line. It's only going to be in a shaded region. So if it doesn't have the line underneath, it's dotted or dashed, and if it has a line underneath, it's solid. So easy way to remember that, solid line underneath, you use a solid line. So you're going to graph it as if it was y equals mx plus b, connect the dots according to the inequality symbol, and then you're going to shade. You might remember picking a point and then shading, testing the region. You no longer have to do that. You're going to shade above the line or below. If the inequality is in y equals mx plus b form, which is slope-intercept form, you read it as y, whatever inequality sign is, x. So for example, if you have y is greater than 3x minus 1, you have y is greater than x. So if something's greater, if you're greater, you're above. So therefore you would shade above the line. If it were less than, you would shade below the line. So example 1, we want to graph x minus y is greater than 3. The first thing we need to do is make sure it's in y equals mx plus b form, except that equal sign will now be in inequality. So we have x minus y is greater than 3. We subtract x to both sides to get y by itself. So we have negative y is greater than negative x plus 3. We can't have that negative y, so we need to divide by negative 1. So we have y is now less than negative and negative become positive, negative and positive become negative, so now we have y is less than x minus 3. Don't forget that if you divide or multiply over that inequality sign and it's a negative, you change that sign. So just like before when we were graphing lines, we need to find the slope and the y-intercept. So the slope, there's that imaginary 1, so it's 1 over 1. We can go up and right or down and left, and our y-intercept is 0, negative 3. So let's plot these. We have 0, negative 3, and we use our slope to go up 1, right 1, up 1, right 1, up 1, right 1, and so on. Now our second step, is it going to be dotted or solid? Since we have just the inequality sign with no underneath line, it's going to be dotted. So we connect it with a dotted line. If you forget to make it dotted on your test or any place, just put, an arrow and say it's supposed to be dotted. Don't need to erase it if you want to. Now we need to read it. Y is less than x. So if it's less than x, you shade below. And there we go. Example 2. Now it's a special line. Is this going to be horizontal or vertical? It's going to be, do you know? Horizontal, because it's y. So y equals 2, that's where we're going to go. So we have a horizontal line. So we go to y equals 2, it's right here. Our second step, it's going to be a solid line because we have the line underneath. So solid line. And now we need to read it. Y is less than 2. So if it's less than 2, we shade below. I want to do another one with just x. I'm going to add it in here. So let's just say we're doing x is greater than 1. So that's a vertical line. And that's at 1, which is right here. Is it going to be solid or dotted? It's going to be dotted because we just have the inequality sign. So we're going to dot this line. And then we read it as x is greater than 1. So since it's greater, there's no up or down in this sense. So if we look left, we go negative. Negative numbers are not greater. If we look right, that's when we get into the positive numbers. So we're going to go right because it's greater than, and that's where all of my positive numbers will be. Example 3, graph the union of x minus y is greater than negative 2 and 2x plus 4y is greater than or equal to 16. So if it says graph the union, that just means to put both of these on the same coordinate plane. So we have our first one. I'll make it green. So we have x minus y is greater than negative 2. Right? It needs to be in y equals mx plus b form. So we need to get y by itself by subtracting x. So we're left with negative y is greater than negative x minus 2. And then we need to get rid of this negative by dividing it out. So negative becomes positive. We flip the sign. Negative becomes positive. And again, negative becomes positive. Now we need to identify a few things. Our m and our y-intercept. So our slope, alright, there's always an imaginary 1 here. So our slope is 1 over 1. So we can go up and right or down and left. And our y-intercept is 0, 2. So we're going to go to 0, 2, plot our point, and go up 1, right 1, up 1, right 1, down 1, left 1, down 1, left 1. Our second step, is this going to be dotted or solid? Well, since we have the less than and nothing underneath, it's going to be dotted. So we have a dotted line. And then we need to read this. It says y is less than. Y is less than x. So if it's less than, we shade below the line. Now we need to do this again for our second line. We'll make this one this nice blue. So our second line, we have 2x plus 4y is greater than or equal to 16. Not sure what's happening there. There we go. So we need to get y by itself by subtracting 2x. So we have 4y is greater than negative 2x plus 16. And then we need to divide everything by 4. So we have y is greater than negative 1/2 x plus 4. We reduce 2 over 4 to 1/2. So we need to find a few things. Our m is negative 1/2, so I can go down and right or up and left. And our y-intercept is 0, 4. So we're going to 0, 4, plot our point, and we're going to use our slope. I'm going to go down and right. So down 1, right 2, down 1, right 2. Now, is this going to be solid or dotted? So our second step is to figure that out. It's going to be solid because we have that line underneath. So solid line, connect it with a solid line. Hopefully you're better at connecting the dots than I am. I didn't get coloring or connecting the dot books when I was a kid, so I'm terrible at it. Blame my parents. I'm not kidding. I'm seriously. I didn't get activity books. I didn't. So our third step is to figure out where do we shade. Let's read this. This states y is greater than x. So since y is greater than x, we shade above the line. So we shade above the line. Now, the solution to this equation, the solution can be found anywhere in this region where the blue meets the green. So if we go back up to this example, that means the solution cannot be on the line. It's only in this blue region. So if it's a solid line, you see how this one's dotted? We cannot pick a number on that line. If it was solid, we could pick a number on that line to make the inequality true. So that's what the shaded region means. Next example, we have 3x is less than 15. So the first thing we need to do is solve for the variable. So we're going to divide by 3. And when we do, we have x is less than 5. So x is less than 5. We're going to pretend that's x equals 5. So I'm going to go to where x equals 5 and draw a line through the x-axis. Now it says less than. So it says x is less than 5. So less than numbers are to the left. Also, the arrow is pointing to the left. Alright, we're going to graph y is less than 2. So we're going to go pretend that this is y equals 2. So y is 2. Draw a line through it. And it says y is less than 2. So less than is down. Let's write the inequality for the given graph. So first thing we need to do is it's solid or dotted. So it's a solid line. That means it's going to have a line underneath. It's going towards the greater, so it's going to be greater than. Since it's a vertical line, it's x equals, and the x it's on is 4. So let's do it again. So it's a solid or dotted. It's dotted. Since it's dotted, we know it's not going to have a line underneath. It's greater than because it's going up. And since it's horizontal, it's y. And the y it's on is 4.